Today we're going to be performing an acid-base titration lab adapted from Flynn Scientific. We'll be using several materials that you typically will use in a lab, like a lab notebook, badges, for duties, distilled water, goggles and gloves, glassware, a magnetic stirring plate with a magnetic stirring rod, a chemical apron, whatever form of antacid you would like to use. Of course, all your procedures. They need to be taped in your lab notebook. Paper towels and pipettes. Be sure that your hydrochloric acid and sodium hydroxide are both 1 molar concentrations and that you've chosen the universal solvent, the universal indicated solution that has a pH range of 4 to 10. Thoroughly review your safety data sheets to ensure that you're familiar with all of the precautions that you need to take using these chemicals, including that universal solution is very flammable, so you want to not have any flame sources in your lab. Your post-lab questions may need you to have your periodic table readily available. So we're going to get started with the procedure. The first thing the procedure asks you to do is to take the small beaker and rinse it with distilled water so that whenever you add the antacid, the milk of magnesia, it will pour out more readily. You want to shake the milk of magnesia before you get started so that any of the settling out that might have occurred will be thoroughly mixed. It's not really a precise amount, but about 10 mils is what we're asking for. The antacid includes both aluminum hydroxide and magnesium hydroxide. And of course, we know that hydroxides are bases. We are rinsing the beaker of as much of the milk of magnesia as reasonably can get. So that extra distilled water in there won't make a difference. We're also going to put some ice in the solution. And so that the cold temperature helps the indicator to be more brilliant in its color. So we want our final volume to be around 200 milliliters. So I'm just adding some ice or some water to the mixture to get closer to the 200 milliliter mark. Next, we're going to put in our magnetic stirring rod. Please remember not to flush this down the drain whenever the procedure is finished and you do your disposal. Because you don't want to get rid of it. It's an expensive piece of labware, so you want to make sure you don't throw that away whenever you're disposing of it. It asks you to put 2 pipettes of sodium hydroxide as well in here to help make sure that you have some good hydroxide ions in there because it's a strong base, so it's going to dissociate. And then a couple of pipettes of indicator solution. You're going to start off with a basic solution, so it makes sense that it is a purple color because purple is the color of a pH of 10. Now, as we titrate this with the acid, you'll notice that we're going to continue to change our range of colors. Also, what's going to happen is for every 2 drops of hydrochloric acid you add, you're going to need to record both the initial color, which as you can tell inside this beaker, there are more than 1 color because it hasn't been well mixed yet. So when you first squirt in the hydrochloric acid, you'll notice that part of it might be a different color, but then as it's mixed, the solution will settle out to be a final color. These colors are important because you're going to take the color that you record and approximate a pH value based on this chart. So if it's closer to purple than blue, you would choose a pH closer to 10. When you get down here, if it's closer to orange than it is to yellow, then you might put 5.2 as your pH. But really, it's a number that you're going to approximate based on the color that you observe. All right, so we're going to go ahead and start our magnetic stirring plate, and that rod that's inside there helps stir the solution for you so that it becomes a well-mixed solution as you're adding your acid. Okay? All right, so we see now that it's a nice purple color, so we're going to continue to put in some drops of acid. Now, after each 2 drops, you need to make an observation, so you'll need to pause the video to make sure you record those. So the first two drops, we don't really see a whole lot of change in the solution, and that's okay because chances are our pH is above 10. So we're going to have to do a few drops to get ourselves down to the 10 mark and start seeing some colors. So now we're at 6 drops, and you can see it's starting to go a little bit more from the purple towards the blue area. 8 drops is definitely more towards the pH of 9. 10 drops of hydrochloric acid. Now we don't see a whole lot of the purple anymore at all, and we're definitely in a lower pH. 12 drops, and we're actually moving towards the green, so you should have a pH of around 8 something. 14. 14 is closer to the pH of 7. 16 drops is again really close to 7. 18 drops. It's beautiful. I don't know if you can tell that there's some pink inside there that then spreads out. Okay. 20 drops. And I think that I would probably call that almost a perfect 7. 22 drops. Now we're going below 7 because it's green, but it's got a lot of yellow in there. 24. 26 drops. See, there's a pink swirl in the middle there. Okay. 28 drops. Hopefully you can see that initial color and then the final color. 30 drops. Okay, we're definitely in the yellow, so you should have around 6 right now. 32 drops. We're moving from the yellow closer to the orange. Again, we're neutralizing all those hydroxide ions. They're all neutralized at this point, so we're just adding more hydrogen ions or hydronium ions. I believe we're at 34 drops. 36. 38. 40. We're not at a pH of 4 yet. 42. You might have to add a few lines to your data table. 44. 46. We're getting closer to 4. The pH of 4. 48. This took a while. 50. I just want to show you how if you added a few more drops, you can kind of get a little bit deeper pink. But no matter how much acid I add at this point, it's not going to change the color because we've run out of range for the indicator. So at this point, this is going to be the last few points in your graph are going to be just a pH of 4, a pH of 4, even though we know that it's below a pH of 4. So when you plot your data on this chart, you're going to start off with a pH of 10 for the first several data points, and that corresponds to however many drops we've added of hydrochloric acid. So you'll have a flattened portion of your graph. Then your graph will start to drop until it reaches a pH of 4, and then you'll have several data points that flatten out at 4 because that's the range of our indicator. The part of your graph that's slanted between the two flat portions, this part of the graph that's slanted, if you'll take the midpoint of the slanted portion of your graph, that is the equivalence point, which should be around 7. It might be 6.5. It might be 7 or 7.5, whatever your data shows. You also have some discussion questions that you need to answer at the end of the lab as well. But before we finish, I want to make sure that you are aware of the proper disposal methods. You don't want to put an acid down the drain like that. Acids are corrosive, as you know. So we want to neutralize this solution, and of 7 is by adding a base, because again, we're trying to raise the pH. So we'll add a few drops of sodium hydroxide so that we can get the color to a more green color and make it more safe to pour down the drain. Now, even though we're pouring this down the drain, we don't want to just dump it down the drain. We want to add a copious amount of water. We always want to flush any chemicals that we're using in the lab, if they're appropriate to be flushed down the toilet or down the drain. You want to make sure that you use excess water. So we're almost to the pre-drain color, so they'll make it safe. All right, that looks pretty good. Again, don't forget that before you pour this down the drain, you want to be able to get your magnetic stirring rod out of there. So we're going to slowly turn this off. We have a nice rod here that we use to capture the stirring rod out of the solution. And you want to rinse that off carefully before you get it ready for the next lab station or next lab group. And then we'll take this solution and pour it down the drain with excess water.
Good luck in your post-lab discussions.